Hello, welcome to our Solving Quadratics Math Notes video. We're just going to walk through what these math notes look like. We've talked so far about how to work with quadratics in these different forms. We talked about standard form, which is just ax squared plus bx plus c. And that is usually equal to 0. We've talked about factored form, which we learned you can have some a value in front, and then you might have like x minus d times x minus f. And you can set that equal to 0. A is our a value, and then these can be our x-intercepts if we set each one equal to 0. And then last form we talked about was our perfect square form, which looks like x minus m squared equals some number. It can be whatever, where m and n are just whatever numbers. So those are the different kinds of quadratic forms we have worked with. Let's talk about how we have solved these different equations algebraically. So we have talked about the factoring and the zero product property. So if it is in standard form, we can use the area model and the diamond to factor. And then we can solve for x by setting each factor equal to 0. And this is called the zero product property. So you guys are very familiar with this. In this example here, we got x squared plus 12x plus 27 equals 0. I'm just going to start by factoring. I'll stick my x squared in a corner, my constant opposite of it. I don't know how to split up the 12x between these two, so I'm going to just stick it in the bottom of my diamond. And then I know that the missing pieces here is going to multiply to whatever this also multiplies to. It'll be equal to that. So I'm going to put that at the top of my diamond, 27x squared. So I want two numbers that multiply to 27 and they add up to 12. I know that 9x and 3x would make this true because 9x times 3x is 27x squared and 9x plus 3x is 12x. So those are my missing pieces. And then you can factor the outside of your area model. I know 9 can go to 9 and 27. X can go into x squared and 3x. X can go into x squared and 9x. And then 3 can go into 3x and 27. So now I have x plus 3 times x plus 9. And I know that is all equal to 0 because I just rewrote this. Sorry, I just rewrote my standard form into factored form. And now because I have something times something equals 0, either this could be 0 or this could be 0 to make this whole equation true. So I'm going to have either x plus 3 equals 0 or x plus 9 could equal 0. And then you can just solve for each equation. So to subtract 3, we get x equals negative 3. Or I could also subtract 9, and I get x equals negative 9. Okay, next up we have completing the square. These are the steps for completing the square. We're first going to move our constant over if we need to. You just want to make sure your x squared and your x are on the same side. Then we're going to draw an area model. Then we're going to cut our b term in half to create our square and then place it in the area model. And then we need to add how much is needed to complete the square on both sides. And then we're going to rewrite it in perfect square form, and then we're going to solve it. So let's walk through this. For step 1, I want to move the constant over. It looks like my constant is already over here, but I have this plus 12 as well, so I need to move that 12 over as well. So let's do that. Minus 12, minus 12. I have x squared equals 8x. Negative 4 minus 12 is negative 16. Okay. I need to make sure my x squared and x are on the same side. So right now, my x squared and my x's are on different sides, so I'm going to move this 8x over here. So I'm going to subtract 8x over, subtract 8x over. Now I have x squared minus 8x equals negative 16. All right, we are ready for step 2, where we get to draw the area model. So slide this up a little bit. I'm going to draw my area model just kind of off to the side here. I'm going to stick my x squared in the area model. And because I want to make a square, I'm going to split up this negative 8x in half. So I'm going to put half of it here and half of here. So half of negative 8 is negative 4. So I'm going to put negative 4x here and negative 4x here. Now I'm ready for number 4. I need to add how much I need to complete the square to both sides of my equation. So I made an x minus 4 square. That's the kind of square I'm trying to make. So if I did negative 4 times negative 4, that would give me positive 16. So I'm missing 16 to complete the square. So I'm going to add 16 here. And whatever I do one side, I got to do to the other. So I'm going to add 16 here, add 16 here. So now I have x squared minus 8x plus 16 equals 0. Okay, Now I get to do step 5, rewrite in perfect square form, and then solve. So x squared minus 8x plus 16 is the same as x minus 4 times x minus 4, or x minus 4 squared equals 0. And now I can solve where I just take the square root on both sides. I have x minus 4 equals, and square root of 0 is just 0. Normally, if it was a different number, I could do a positive or negative version of this, but a positive 0 is the same as a negative 0. So I just have the one answer here. And then I just add 4 over to solve for x. So I know that I have an x-intercept at 4 in this example. All right. The third way that you guys have learned how to solve a quadratic formula is, a quadratic equation is using the quadratic formula. So our first step is to make sure that our equation is equal to 0. This formula only works if it's equal to 0. Then we're going to rewrite it in standard form. That just helps us keep our A and B and C correct. So standard form. And then we got to identify our A, B, and C. So we'll identify our A, B, and C. And then we'll substitute those into the quadratic formula. And then boom, we have our x-intercepts. So let's first start with step 1. I want to make sure my equation is equal to 0. It is not equal to 0. It is equal to 60x right now. So I'm going to subtract 60x on both sides. And now I have 36x squared. I can't combine 60x with the x squared or with the 25 because they're not like terms. So I'm just going to keep going. 25 minus 60x equals 0. All right, my second step is to rewrite in standard form if needed. Remember, standard form means I have my squared, then my x, and then my constant. So I'm going to rewrite this. So I have my squared, my x, and then my constant. So I'll do 36x squared minus 60x plus 25 equals 0. And now I'm ready for step 3, A, B, and C. So my A is just my coefficient in front of x squared, which is 36. My B is my coefficient in front of x, which is negative 60. And my C is my constant, which is 25. So now that I have these, I can just stick into the quadratic formula. Here we go. X equals, remember to use your parentheses, especially with these negatives. Okay, so x equals negative b, so I'm going to make sure it's negative parentheses negative 60 plus or minus the square root of parentheses. I'm sticking in b squared, which is negative 60 squared, minus 4 parentheses, and I stick in my a value. My a value in this case is 36, so 36 parentheses, another parentheses for my c, a times c here, and c is 25. Okay, and then that is all over 2 times A. Again, A, in my case, is 36. All right, so now I can just simplify each section. So now I got negative times negative 60 is just positive 60, so x equals positive 60 plus or minus the square root. And then we're just going to type everything underneath the square root in our calculator. So I'm going to grab my calculator right here. Oh, that looks a little better. Okay, so we're going to do we're going to do parentheses, negative 60 squared minus 4 times 36 times 25. And again, using those parentheses, and that gives me 0. Ooh, interesting. All right, so we got 0, and then we put it over 2 times 36. You can type that in if you want to, and that would be 72. All right, so normally this would split off into 2 equations, right? 60 plus square root 0 over 72 and 60 minus square root 0 over 72. But if I do square root 0, I just get 0. So I end up with 60 plus or minus 0 over 72. So this one is an example where I only have one x-intercept as well. So I have 60 over 72. X equals 60 over 72. You can leave it as that. You could also simplify your fraction if you wanted to. I think if you divided both of them by 12, you would get 5, 6. Oh, 5, 6. Which is the same as 0.833 repeating. So there's a couple different representations you can do here. Oh gosh, sorry. So yeah, you could do 60 over 72 or 5, 6 or 0.83 repeating. Alrighty, so that's a quick recap of the 3 different ways that we have solved these quadratic equations. You can use factoring zero product property, you can complete the square, or you can do the quadratic formula. A key thing that I don't know if we've hit on too much in the class, but when you complete the square, you have to make sure your a value is equal to 1 or you aren't able to do this perfect square splitting up idea. So that is key. And not everything's factorable, but we know that the quadratic formula works every time. But it's just a little bit of a process. So if you already can factor, that's a little faster, right? Okay, here we go. We're going to move on to special cases onto the back side. All right, so when we're looking at factoring the zero product property, if the equation is already factored, just do the zero product property. I don't have to go through and like multiply this out and then try to refactor it or do the quadratic formula. You can, but if it's already set up to be equal to 0, it's way easier just to set each factor equal to 0 because I have something times something is 0, so either one could equal 0. So I got 3x minus 4 could equal 0 or 2x minus 1 equals 0. And then you'll just solve for x. I'll add 4 to both sides. Got 3x equals 4. And then you can undo multiplication with division. So I'm going to undo a multiply 3 with divide 3. And then that's one of my x-intercepts, 4/3. I can do this again. Plus 1, 2x equals 1. Divide out that 2. And then I have x equals 1/2. So that's my other x-intercept if I were to graph it, or these are my solutions. This is also another special case with factoring and zero product property. If your equation does not have a c term, if you have no constant term, right? Here I only have the x squared and x, I have no constant term. You can just use the greatest common factor to help you factor and then just do the zero product property because they both have an x in common. So I can just pull out an x. And because they both can be divided by 2, I'm going to pull out a 2 as well. You can pull out a -2 or a +2. I'll just pull out +2 for now. So I got to figure out 2x times what would give me -2x squared. And you can draw this in an area model if you want to, like we've done before, but you don't have to. So it's like we pull the 2x out here. So I want to figure out 2x times what gives me -2x squared. That would be -x. And then 2x times what gives me 8x. That would be +4. So now I have -x plus 4, and then that equals 0. And then I can set each factor equal to 0 like before. I got something times something equals 0. So either one could be 0. So now I got 2x equals 0 or -x plus 4 equals 0. And then I can solve for x. So I'm going to divide this side by 2. And whatever I do to one side, I got to do to the other. And now I have x equals 0. That's one of my answers. Here I can subtract the 4 and then divide by -1, but it'd be faster to just add the x over since it's a -x. I could just make a positive x by moving over. So now I have 4 equals x. And that would be my other x-intercept. Again, this would be a lot easier than maybe doing the quadratic formula, which you could do. Get your a, b, and your c would just be 0, but then you have to go through the whole quadratic formula when this is a little faster. Okay, let's look at completing the square. Here's some special notes for completing the square. If an equation is already in or close to perfect square form, move over anything so it's just the perfect square on one side of the equation. Sorry, move over anything so it's just a perfect square on one side of the equation. And then you can just solve by taking the square root. So by taking the square root. So this is already in perfect square form. I have something in parentheses squared, which is pretty great. So I want to square root this, but I'm not quite ready yet because I have this +3 in the way. So I'm going to -3, -3. Now I have 2x minus 5 squared equals 13 minus 3 is 10. And now I can just do my square root step. So again, this is a lot faster than trying to do like multiply this all out and then do the quadratic formula or whatever, right? Like this, it's faster just to move it over and now you can just do your square root jazz. All right, I'm square rooting both sides to undo that square root. Because I have something squared is square root 10, I could either have a positive version, squared is square root 10, or then 2x minus 5 could equal a negative square root 10 because square root 10 all squared is 10, or negative square root 10 all squared is also 10. You can turn this into a decimal if you want to. I'm just going to leave this in exact form, but you can turn it into like the 3.16 decimal if you want to. So we got 5, add 5. We got 2x equals square root 10 plus 5, divide by 2. divide everything by 2. And now I have x equals square root 10 plus 5 over 2. And then I have the same thing, but just with a negative square root 10 instead. So add 5, 2x equals negative square root 10 plus 5, divide out by 2, divide out by 2. So now I have negative square root 10 plus 5 over 2. So those would be my two x-intercepts. You can turn them into decimals if you wanted to instead, but that's fine for now. All right. Another special, oh wait, sorry. This kind of looks a lot like the quadratic formula, right? You you can see that square root plus and minus kind of idea happening. Okay. All right, if an equation has no b term, so I don't have anything with an x, no b term, you can also just use the square root to solve. So this one, it doesn't look like it's in perfect square form, but the x is being squared, so I just have something squared minus 121 equals 0. So I don't have to factor this or use a quadratic formula. I could just add the 121 over, and now I have 4x squared equals 121. And I want to get x squared by itself, but right now it has that multiplied by 4 in front, so I'm going to divide by 4 to undo it. And now I got x squared equals 121 over 4. And now you can take the square root on both sides. So I'm going to square root. Again, this gives me two different answers. I could have a positive square root 121 over 4, or I could have a negative square root 121 over 4. You can actually simplify this further. You can type in a calculator if you want to, but square root of 121 over square root of 4 is the same as 11 over 2. So you just have a plus or minus 11 over 2, which is 5.5. So x could equal positive 5.5 or negative 5.5. Or you can leave them as fractions too. Okay. Let's check out this last example here for our quadratic formula. We have a special note here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's our quadratic formula. So we may need to move over multiple terms in order to make it equal 0, So looking at this, I don't really want to factor that. That looks hard to factor. This would be annoying to complete the square with as well because I'd have to like divide everything by 20 and it wouldn't really clean up nicely. So this seems like a good candidate for using the quadratic formula, but I have to make sure it equals 0 first. So in order to do that, I got to move these to the other side. So I'm going to undo this positive 2x by subtracting 2x. And now I have 20x squared, and I can combine the negative 30x with the negative 2x, so that gives me negative 32x equals, and then I'm just left with 25 on the side, since I subtract the 2x over. I have a positive 25, so to undo a positive 25, I'm going to minus 25. Subtracting 25, I can't combine that with x squared or x, so it just stays. 20x squared minus 32x minus 25 equals 0. And now we can see here we've got a lot of really large coefficients, so the quadratic formula is a good way to go. So my a value is 20, my b value is negative 32, and my c value is negative 25. So let's stick into the quadratic formula. We got x equals negative, parentheses, b, I'm sticking in negative 32 in, so we'll do negative 32, plus or minus the square root of b squared, which is negative 32 squared, minus 4 times a, which is 20, times c, which is negative 25, all over 2a, which is 2 times 20. All right, and now we can go through and simplify each section. So I can simplify this section, which would be positive 32. Negative times a negative is a positive 32. Plus or minus square root. And again, I can simplify this whole section by typing it in my calculator. So let's grab my calculator here. I can type in parentheses, negative 32, close parentheses, squared, minus 4, parentheses 20, and then another parentheses, negative 25. All right, so under my square root, or it's also called the discriminant, that's a fancy word for it, but 3024. So I'm at 3024. I just turned all of that into 3024. And now we're going to divide that by 2 times 20, which is 40. All right, next up, we can simplify by taking the square root of 3024. So I'm just going to do the square root, second, x squared. of 3024. And I get 54.99. So almost 55. I can leave this in this form if I want to, or I could keep it as 54.99. Anyway, so I'll try one with the decimal answer since I left this one in exact form. So I'll try the approximate answer. So I have x equals 32 plus or minus 54.99 over 40. And again, this splits into two different answers. I could have 32 plus 54.99 all over 40, or I could have 32 minus 54.99 all over 40. So now that I have these, I just got to type this in to simplify it. Remember, when we're typing this in on our calculator, we can't just type it in like 32 plus 54.99, and then if we just hit divide 40, my calculator is only going to divide that 54.99 by 40. It won't divide the whole top of my fraction by that. So if you want to type it all in one go, just make sure you do parentheses around the top and then divide by 40. So I'll do parentheses 32 plus 54.99, close parentheses, and then divide by 40. All right, and then that gives me 2.17475. Okay, that's one of my decimals. And then if I did it with the other one, I can just hit the up key and just change that to a subtract sign. And now I got my other x-intercept, which is negative 0.57475. So those are my two x-intercepts as approximate answers. On derivative, it'll want you to write it as an exact answer. So you'll have to type it in as 32 plus square root of 3024 all over 40. And then you'll also have to do comma 32 minus square root of 3024 all over 40. And so you'll have to type it in like that on derivative. But these are the decimal approximations of these exact answers. This is your exact answer. And then these are your approximate answers. Okay. Thanks so much for going through this review with us. Hope you're having a great time. We'll see you. Bye.